Installing the manifold. The manifold performs a number of functions. Primarily, it distributes water from a central location to various rooms in the house. A length of pipe has only a limited capacity to carry heat, so there is a limit to the effective length of a single pipe-run circuit. When you have a large room, or the room is a long way from the manifold, it may be necessary to use a number of circuits. The number of outlets on the manifold will be dictated by the number of circuits it's feeding. The JG manifold has our standard 15mm push-fit connections for ease of use and enables the UK standard pipe size to be used. As you can see, we have an automatic air vent, fill connection, and on the bottom we have the drain connection. On the opposite ends we have two isolated valves. The flow is on top and the return is connected to the bottom rail. We have temporary decorators caps on the bottom rail. These are used for isolation and adjustment of the circuits and will be replaced by electrically operated actuators at the commissioning stage. The actuators allow the user to control each room individually. The flow meters on top of the manifold give a visual indication of the amount of water flowing through each circuit. The amount of flow needed will depend on the length of the circuit and the temperature drop required. Generally, the shorter the circuit, the more restriction will be needed. This is called balancing the system. Setting the flow is achieved by lifting the locking ring at the base of the flow meter and turning the adjusting nut. The mixing valve. The JG control unit comprises a pump and an adjustable blending valve at the bottom. Because the water is too hot to be fed into the floor unblended, the manifold is coupled with a JG control unit. The control pack is connected to the isolating valve on the manifold using the washers provided. It performs a number of functions. It blends high-temperature water from the boiler with the water in the UFH system to maintain a designed temperature, usually between 40 and 60 degrees, depending on the application. It also circulates water around the various UFH circuits. Be aware that this pump will not circulate to and from the boiler. For difficult locations, we have manifold elbows as well as manifold extensions. Fitting the manifold to the wall. The manifold must be located as centrally as possible to the circuit it's feeding, allowing enough height to accommodate the installation and screed depth. Filling the manifold. Due to the large quantity of pipework, it's important to follow the correct procedures to minimise the amount of air in the system, which can lead to problems with testing and operating the system. Open all flow gauges at the top of the manifold by lifting the locking cover and turning the adjuster anti-clockwise. Connect the fill point to a hose pipe and the drain connection to a bucket or drain. It's important to ensure the water is forced around the UFH loops one at a time to prevent short-circuiting from one manifold rail to the other. First, close all the decorators caps to isolate the circuits. Then, starting at the furthest end of the manifold, open only one of the decorators caps. Flush the water around the loop until all the air is purged. Close the cap and open the next circuit. Repeat the process until every circuit is purged. When completed, close the bottom valve, shut off the water supply and close the top valve. The system is now ready for pressure testing. Pressure testing the manifold. Turn off any electrical equipment. Isolate the manifold from the heating system by turning the ball valves to the off position. Open all flow gauges at the top of the manifold by lifting the locking cover and turning the adjuster anti-clockwise. Ensure all temporary adjuster heads are in the fully open position by turning anti-clockwise. Connect a suitable pressure testing kit to one of the fill valves. With the valve open, pump up the pressure to 2 bar. Isolate the pressure at the tester and leave for 10 minutes while checking for leaks or pressure drops. If all is well, increase the pressure to 10 bar and leave for a further 10 minutes while checking for leaks or pressure drops. If all is well, reduce pressure to operating pressure. Screeded floors should be left to approximately 6 bar until the screed has been laid and dried to protect pipework from damage. A variety of screeds can be used, such as sand, cement or a flowing screed. The screed is typically 50 to 65 mm thick. When laying the screed, care should be taken to ensure that the screed is compacted around the pipe properly. Most screeded floors require 28 days after laying before preheating can begin. However, calcium sulfate screeds may need only 7 days after laying. Check with the manufacturer for specific drying times. Under no circumstances should the UFH be used for speeding up the drying period. If the UFH is being installed when there is a possibility of freezing conditions, suitable antifreeze should be added to protect the pipework. The system will need to be flushed out and refilled prior to operation. When turning on initially, the temperature of the blending valve should be set to the lowest setting, 25 to 30 degrees, and run for 2 to 3 days before building up the temperature over the next couple of days.